So in this question, an athlete with a mass of 70 kilograms, so mass of the athlete is 70 kg, trains by performing press ups. So these are the press ups he's performing, as you can see in the picture, with a load on his back. So he put some load on his back and he's doing up press ups. The diagram shows a perpendicular distance involved. So diagram is representing the perpendicular distance. The center of the mass of athlete is cm. So this is the center of the mass of athlete, means the point where the gravitation, he's feeling the gravitational force of the earth or pull of the earth, and center of the mass of the load, that is cl. So it means this is a position where the load is experiencing the force of gravity. The mass of the load is 6 kilogram. In the question they're saying what is the upward force exerted by his two arms. So we need the upward force exerted by his two arms. So now I will represent the forces. So there's a first thing, there's an upward force of the arm. I will use another color so that it will be visible. So this is the upward force of the arms. Then the weight of the load is acting downward, because weight is always acting downward. So the weight is acting downward. And what will be the value of the weight? Because they mentioned the mass of the load is 6 kilogram. That's a mass. So how we can get the weight? As we know, weight is equals to mass multiplied by gravity. So mass is equals to 6 and the gravity is 10. So 6 multiplied by 10. So the weight will be equal to 60 Newton. So there will be a 60 Newton force downward because of the load, and the weight of the athlete, as they mentioned, the mass of the athlete is 70 kilogram. So if the mass of athlete is 70 kilogram, the weight will be equal to 70 multiplied by 10, which is equals to 700 Newton. So weight of the athlete will be 700 Newton. The weight of the load is 60 Newton, and there's an upward force by the arms that we don't know, and that is what we have to find. Now, what is a pivot here? Pivot, a point around which the object can rotate. So this athlete, as he is doing the press ups, so he can move down or up. So what is the point of the rotation, around which point he is rotating around his feet? He is rotating. So this is the point of rotation, or this will be the pivot. Is it clear? First thing, the forces, the direction of the forces, then we'll solve the question. But first thing, you should identify the point of rotation, a pivot. Then you should show the arrows to represent the direction of the forces. The weight is always acting downward. That's why both weights, weight of the load and weight of the athlete, is acting downward. And as they mentioned, the upward force from the arms, so the arms are applying an upward force, so that is pointing up. Now what happened? Because of the load, because of the weight of the athlete, which direction he will tend to rotate, clockwise or anti-clockwise? Because of his own weight, which direction he tend to rotate? Is it a clockwise or anti-clockwise? So there is a weight of the athlete. This is a pivot. As he moves downward, which direction this showing a rotation, clockwise or anti-clockwise? So this is anti-clockwise. So this is anti-clockwise rotation. That's right. What about the weight of the athlete and the load as well? So weight and load both are causing an anti-clockwise rotation. Because of the weight, he tend to move anti-clockwise. Because of the load, he tend to move anti-clockwise. And as he try to apply an upward force, so because of the upward force, which direction he tend to rotate? He tend to rotate clockwise. So The two weights are causing an anti-clockwise rotation. Because of the two weights, it is causing an anti-clockwise rotation, and because of the upward force, that will cause a clockwise rotation. And if whenever we are solving a question, what we assume? We assume that the object is in equilibrium or object is balanced. So when object is in equilibrium, because to solve these questions, we have to assume that object is in equilibrium. So we can say the clockwise moment, or we can say the anti-clockwise moment is equals to the clockwise moment. So weight of athlete is causing a clockwise moment, anti-clockwise. Load is causing an anti-clockwise moment, and the upward force of the arm is causing a clockwise moment. So how to solve this question? We will calculate the moment. The total anti-clockwise moment is equals to total clockwise moment. Now, what is the moment caused by the weight of this athlete? The weight of the athlete is 700. The mass is 70 and the weight is 700. So weight is equals to 700 multiplied by distance from the pivot. So what is the distance between the weight and the pivot? The perpendicular distance between the weight of the athlete and the pivot, the point of rotation, the perpendicular distance. So it's given 0.9. So it will be 700 into 0.9. So 700 into 0.9. Same way, the load is also causing an anti-clockwise moment. So plus, because the load is causing a moment in the same direction, and when moments are in the same direction, we add them. So it will be 60. The load is equals to 60 multiplied the distance from the pivot. So what is the distance between the perpendicular distance between the load and the pivot? So 0.3 plus 0.9, so that's equal to 1.2. So 60 multiplied by 1.2 equal to the clockwise moment. So this force is causing a clockwise moment. So force is F multiplied by perpendicular distance from the pivot. So this perpendicular distance from the pivot, that's equal to 0.1 plus 0.3 plus 0.9. So the total sum will be equal to 1.3. Is it clear till this point? The total anti-clockwise moment is equals to total clockwise moment. So the weight of athlete is acting downward. The weight of the athlete is acting downward. Load is acting downward, where arms are applying an upward force that they mention in the question. So this is causing an anti-clockwise moment. This is causing an anti-clockwise moment, and the upward force is causing a clockwise moment. And this is a pivot, the point around which the object is rotating. So we call that as a pivot. So whenever we are solving a question related to moment, we always consider that object is in equilibrium. When object is in equilibrium or balance, we say the anti-clockwise moment is equals to the clockwise moment. So anti-clockwise moment, what is the anti-clockwise moment? The weight of the athlete is 700 Newton. the weight of the load mass is 6 kilogram, but the weight will be 60 Newton. So how to calculate a moment due to the weight? So the moment is calculated by force into distance. So what is the moment or turning effect caused by the weight of the athlete? That is 7, and it is anti-clockwise, so that is 700. That is the force multiplied by distance between the force and the pivot, the perpendicular distance. So what is this perpendicular distance? That's already given in the question, 0.9. So 700 is the force, and the distance between the pivot and the force is 0.9. So 700 into 0.9. From where I got these values, Abdullah, as you can see, they mention the mass of athlete is 70 kilogram. So if the mass is 70, what will be the weight? Because weight is the force. So weight is mass multiplied by gravity. So 70 multiplied by 10, we will get 700. And the mass of the load is 6 kilograms. So this object is 6 kg, but the weight is the force. So weight is mass multiplied by gravity. Mass is 6 and the gravity is 10. So that is equals to 60 Newton. Because we need the force, we don't need the mass, we need the force, and weight is a force. So 700 Newton is the weight of the athlete multiplied by perpendicular distance from the pivot, that's 0.9. Plus there is also another anti-clockwise moment that is caused by the load. So the force is 60 because the weight of a load is 60 multiplied by perpendicular distance from the pivot. So what is the distance between the pivot and the load? 0.9 plus 0.3, that's equal to 1.2. So it will be 60 multiplied by 1.2. So these are causing an anti-clockwise moment, and then the force, the upward force of the arm is causing a clockwise moment. So what is the clockwise moment? The force of the arm, which we don't know, we say F, multiplied by distance from the pivot. So what is the distance from the pivot? That's 0.9 plus 0.3 plus 0.1. So the total distance will be equal to 1.3. Is it clear till now, this equation? Then we will solve 700 multiplied by 0.9. That's equal to 630. So this is 630 plus 60 multiplied by 1.2 equal to 72, and F multiplied by 1.3. Then 630 plus 72, that is equals to 702, is equals to F into 1.3. 1.3 is multiplied, other side it will divide. So 702 divided by 1.3. So 702 divided by 1.3, we will get 540. We are calculating the force here, the upward force of the arm. We are not calculating the weight, but we have to calculate a weight first, because without the weight, we cannot get the upward force. So the total upward force exerted by the two arms, that is equals to 540 Newton. So I'll quickly repeat. Look what happened. They give you the mass of the athlete. The mass of the athlete is 70 kg. The mass of the load is 6 kg. But mass is not the force, weight is the force. So weight of the athlete will act downward, and weight of the load will also act downward. And weight of the load will be 60 Newton, and weight of the athlete will be 700 Newton. And around about the pivot, which direction they will try to cause a rotation? Both will try to cause an anti-clockwise rotation. But as athlete is doing a press up, so he is applying an upward force by using his arms. he is applying an upward force, and his upward force, which direction this will cause a rotation? It will cause a clockwise rotation. So basically we are finding this force exerted by the athlete, the arms of athlete. So the clockwise moment is equals to anti-clockwise moment, and so it will be F into the total distance. We always take the distance from the pivot. So this total distance is the distance of force, this one is the distance of load, and this one is the distance of the weight of athlete. That's why the final answer is 540. Is it clear now? 700 into 0.9 plus 60 into 1.2. Okay, another question. A uniform rod has a weight of 2 Newton. So when they use the term uniform, it means there will be a weight at the center. So they did not draw that weight. You have to draw that weight. So a uniform rod is there, which is having a weight of 2 Newton. The total length of the rod is 80 centimeter. So if the length of the rod is 80 centimeter, where the weight will act? So weight will act at the center. And what will be the weight? They mentioned that is equals to 2 Newton. So weight will act at a 40 centimeter mark. That's right, because half of 80 will be 40. So exactly at 40 centimeter, there will be a weight. A rod is suspended by a thread. So we attach a thread here. So a rod is suspended by a thread at 20 centimeter from end X, and a weight of 5 Newton is suspended. So we attach a weight of 5 Newton. A student hang a 6 Newton weight so that it is in equilibrium. What is the distance of 6 Newton weight from end X? So first thing, because the weight is acting at the center, so from both sides it is 40 centimeter. So this is 40 centimeter. This one will also be 40 centimeter. Now, what should be this distance? This should be 20 centimeter because total is 40. So one side is 20, the other side should also be 20. So if I draw this rod again, just to explain the idea. So we have rod X and Y. And we attach a thread here. Here we have 5 Newton. And here we have 2 Newtons. This is 20 centimeter mark. This is also a 20 centimeter mark. So basically this is a pivot around which the object can rotate. Which direction this 2 Newton will cause a rotation? Clockwise or anti-clockwise? Which direction this 2 Newton is causing a rotation? It is in same as the direction in which the hands of a clock rotate. So that is clockwise, because it is in this manner, same as the direction in which the rotation of the clock hands. And which direction the 5 Newton will cause a rotation? So it will cause an anti-clockwise rotation. But what they mention here in the question, that a student, yeah, the thread is holding this rod, and around this the object can rotate. So because of its weight, it can rotate clockwise. Because of the 5 Newton, it can rotate anti-clockwise. But it will not be balanced. Why it will not be balanced here? Because the moment caused by the 2 Newton force will be smaller as compared to moment caused by 5 Newton force, because they are at the same distance. So what a student hangs a 6 Newton weight so that it will be in equilibrium. It will balance. So where I should attach a 6 Newton weight? On the right hand side of the thread or the left hand side to balance it? Because right now the clockwise moment is smaller. That's 2 multiplied by 20, which is 40. And anti-clockwise moment is 5 multiplied by 20. That's equal to 10. So where I should attach a 6 Newton load? On the right hand side or on the left hand side? So I should attach on the right hand side. So I should attach on the right hand side. So we should attach a 6 Newton load on the right hand side, and from a distance from the pivot or the thread is x. So basically, what are the forces here? The weight of the thread is the weight of the beam is acting downward, which is 2 Newton. So we also attach another load of 6 Newton, and the distance between the pivot, the thread, the pivot, and the load is x. X means we don't know. So when we attach a 6 Newton load, it will be balanced or it will be equilibrium. So it means the anti-clockwise moment balances with the clockwise moment. So whenever it is in equilibrium, the anti-clockwise moment balances with a clockwise moment. Now the anti-clockwise moment, what is the anti-clockwise moment? That force is 5 multiplied by distance from the pivot, because this rod can rotate. So what is the distance from this pivot? That is 20. So F multiplied by 20 equal to the clockwise moment. So what is the clockwise moment? The clockwise moment is due to two forces. One is 6 Newton, another one is 2 Newton. So 6 Newton is causing a clockwise rotation, and the distance from the pivot is x. X means unknown, plus a force of 2 Newton. The formula for moment is force multiplied by distance. And when object is in equilibrium, the total clockwise moment is equal to total anti-clockwise. So force is 6 and the distance between the pivot and the force is x, unknown. So we write x. Then there is also another clockwise moment because of force of 2 Newton. And what is the distance between 2 Newton? What is the distance between 2 Newton force and the thread? That is equals to 20 centimeter. So 2 multiplied by 20. So 5 multiplied by 20, that's equal to 100. 6x, 2 multiplied by 20, that's equal to 40. 40 is added here, other side it will be subtracted. So 100 minus 40 is equals to 6x. 100 minus 40 is equals to 60. So 60 is equals to 6x. 6 is multiplied, other side it will divide. So 60 divided by 6 is equals to x. So value of x is equals to 10 centimeter. But if you read the question, what they ask what is the distance between 6 Newton and x. So this value of the x, this distance is coming out 10 centimeter. But what distance they are asking? They are asking a distance between the end x and 6 Newton. So what is the distance between the end x and 6 Newton? So 20 plus 10, so that is equals to 30. So D will be the right answer. Is it clear, this question? So whenever you're solving a question related to turning effect or a moment, first thing what you have to do, you have to show the direction of the forces, and always keep in mind the weight of the object is there. If it's a uniform object, it will act at the center. So they don't show, normally they do not represent the weight. So you have to draw the weight first, because some student without drawing a weight, if they try to solve this question, they will get the wrong answer. Okay, another question. A wooden plank rests in equilibrium on two rocks. Three forces are acting. How are the size of the forces when it is in equilibrium? Equilibrium means it is balanced. When it is balanced, there are two conditions: no resultant moment, or we can say, if we say that according to first condition, no resultant moment, so we can say the anti-clockwise moment is equals to clockwise. And the second condition, there is no resultant force. So if no resultant force, we can say the upward forces equal to the downward forces. So what are the upward forces? P and R are acting up and Q is acting down. So it will be P plus R are the upward force, that is equals to downward force equal to Q. So what will be the right answer? B will be the right answer. Is it clear, this question? To everyone, anyone having a doubt, or if you want me to repeat any question, you can just let me know, so I will repeat. This question I want everyone to solve. Look, they mention a uniform plank. I will give you a hint, but I want everyone to participate and try to solve. A uniform plank rests on a pivot, so at the center. So weight of a plank is acting downward, but that will not cause any rotation. Why it will not cause any rotation? Because it is acting on the pivot. It does not have any distance. That's why the weight of the plank does not cause any rotation. So mass of the child P is 25. So this is child P. He is having a mass of 25 kg. So if his mass is 25, what about the weight of this child? Weight will be equal to 250 Newton. And the weight of a child Q, we don't know, that we want to find. So that is the weight of child Q. We say W. Which direction the weight of the child P will cause a rotation? Clockwise or anti-clockwise? You have the formula: weight is equals to mass multiplied by gravity. Mass of an object is 25 and the gravity is 10. So when 25 multiplied by 10, weight is equals to 250 Newton. Because weight is a force, mass is not the force. So weight of the child P is 250 and it is at a distance of 1.2, it is causing an anti-clockwise movement. Weight of child Q is acting downward as well, and it will cause a clockwise rotation. As they mentioned, the plank is balanced. It is in equilibrium. So when something is balanced, we can say the anti-clockwise moment is equals to the clockwise moment. The anti-clockwise moment is 250 multiplied by distance from the pivot, that's equal to 1.2. Clockwise moment, that is the weight of child Q multiplied by distance, that is 1.5. Why we did not take the weight of the plank? Because it is acting at the center, so it does not cause any rotation or turning effect. So when we find, it will be 250 multiplied by 1.2 divided by 1.5. So what will be the weight of child Q? So weight of the child Q, that is equals to 200 Newton. But in the question, they're not asking for weight. What they're asking for mass of child Q. How to get the mass? So you have the formula, weight is mass into gravity. So weight is 200, mass is unknown, and gravity is 10. So 10 is multiplied, other side it will divide. So that is equals to 200 divided by 10, which is equals to 20 kg. So the correct answer will be A. Is it clear, this question? Then there is also a very short method. If you recall the concept, of the heavy and the lighter, yesterday we discussed, heavy objects are placed closer to the pivot and lighter objects are placed away from the pivot. So it means, because the child Q is lighter than child P, that's why the child Q is away from the pivot. It's having a less weight or less mass, and child P is having more weight or mass. So if mass of the child P is 25, so it means mass of child Q should be less than 25. So it should be less than 25. Which option is less than 25? It cannot be D, it cannot be C, it cannot be B. So it will be A. So you can use your understanding the concept of the topic to answer this question without calculation, or if you find calculation easy, you can use the calculation and work out the final answer. Is it clear, this question? In MCQs, in multiple choice question, they don't ask for the working. They normally want you, because there's a separate answer sheet, so they want answer from you. How you work out, how you got the answer, that is not they check for, is paper 2, the MCQs. For structured question, yes, there are the writing a formula is having a mark, getting the showing calculation and getting the answer is having marks. But in paper 2, it does not depend how you approach the question. What is important is the final answer. So even if you are getting the final answer by calculation, by your understanding, or from your neighbor, that does not make difference to the marking. Okay, in this question, the diagram shows a wooden beam which is having a negligible weight. So the beam is having a weight, but that is negligible. When they say negligible, it means it is very small, or you can neglect. You don't consider. So no need to consider, it's very small. And it is attached to a wall by a hinge. So this is a hing, the point where this beam is attached. Kept horizontal by a vertical rope. So this is a rope which is keeping it horizontal. The weight of the person is acting downward. The length of the beam is 3 meter. A man of weight 800 Newton walk along the beam from P to Q. What is the distance of the man from P when the tension in the rope become 500? So if the tension in the rope, tension is when we apply force by using a rope, we call that as a tension. So tension in a rope is 500 Newton. Weight of the man is 800 Newton. So if this is a P is the point of rotation or a pivot, which direction the weight of the man will cause a rotation? What is the direction of rotation for weight of the man? So that is clockwise. And which direction the string will cause a rotation? That will cause anti-clockwise. And because the beam is balanced, so if it is balanced, the anti-clockwise moment is equals to clockwise. So anti-clockwise moment, that is 500 multiplied by distance. As they mentioned, the length of a beam is 3 meter. So if this total length is 3 meter, so what is the distance between the pivot and the load, this string? That is equals to 3. Multiplied by clockwise equal to clockwise moment. The weight of the man is 800 and the distance between the man and the pivot is unknown, so that is x. So that is unknown or x. So 500 multiplied by 3, that's equal to 1500 equal to 800x. 800 is multiplied, other side it will divide. So 1500 divided by 800, that's equal to 1.875, which is approximately equal to 1.9. So C will be the right answer. Is it clear, this question? So whenever we are solving the question related to equilibrium, yeah, length of the beam is 3 meter. So if the length of the beam is 3 meter, Abdullah, you can see this total length is 3 meter. So, and the rope is applying a force of 500. So what is the distance between the rope, the 500 Newton force, and the pivot? That's 3 meter. And the man is walking and he's not at point Q. They mention a man walk along from P to Q. What is the distance from P when the tension is Q? 500. Not length of the rope. We did not consider length of the rope. The length of the beam. This is the length of the beam. The length of the beam is 3 meters and the force is 500 Newton. We don't have to consider length of the rope. We have to check the perpendicular distance from the pivot to the force, that is equals to length of the beam. And the weight is acting downward and the distance is unknown x. So we calculated that the man is actually 1.9 meter away from this position.